In the last video, we spoke about CryptoKitties, which is the first real-world example of a dApp or decentralized app. To actually design these dApps or smart contracts on the Ethereum network, it requires a language, and this language that Ethereum has put out is called Solidity. If you want to learn Solidity, there are the docs available on solidity.readthedocs.io. However, there is an easier, more interactive way, which we'll be going through today. It's called CryptoZombies, and let's get started with it. It does rely on the user having some background knowledge in programming, but nothing too intense. So we're going to, in lesson 1, just populate an array of zombies. Let's get started. This part just shows us that changing characteristics of a zombie will change the zombie's DNA. Okay, so if you're used to object-oriented programming, a contract would basically be your class. So we told here to create a contract called Zombie Factory. And we'll need to specify the version of Solidity that we're using, it being 0.4.19. And let's check that. So it gives us an error, and we see that it's a semicolon missing. Oh. And there we have it, lesson 1, chapter 2 completed. Let's move on to chapter 3. Against simple variables and integers, what do we have to do? Declare an unsigned integer. An unsigned integer is basically an integer that only has positive values, and name it DNA digits. Set it equal to 16. If we follow the example syntax, there will be an unsigned integer by the name of DNA digits equated to 16. Terminate. Chapter 4, Math Operations. This seems similar to almost any other language. It supports the exponential operator, which is asterisk asterisk being to the power. So we need an unsigned integer named DNA modulus and set it equal to 10 to the power of DNA digits. DNA digits is still there from our previous chapter. Unsigned integer, name it DNA modulus, and set it equal to 10 to the power . Forgot the semicolon. Chapter 5, Structs. If you're used to object-oriented programming and haven't come across structs, a struct is basically a user-defined variable type, such as we already have a string and unsigned integer, which has their own characteristics. A struct of person will have the characteristics of an age of an integer and the name of a string. These are typical computer science terms. It's nothing language specific. So we're going to create a struct called zombie. Sorry, it is case sensitive. And give it two properties. A name, which is of string type, and the DNA property, which is of unsigned integer type. We move on to arrays, and we are asked to create a public array of zombie structs and name it zombies. CryptoZombies does tell us that public here would allow anyone on the blockchain to access it. So let's go ahead and do that. Remember, zombie is the data type of the struct, and zombies is the name of the specific array. Now we move on to the fun part, functions. What are we required to do? Create a function named createZombie. It would take two parameters, name and DNA. Notice that the underscores, we'll see in a later chapter that the underscore is used to differentiate between global and local variables. So our function will be called createZombie. And it has two parameters, name of type string, and DNA of unsigned integer. Does not ask us to label it as public or private, so I'm sure that should be fine. Chapter 8, working with structs and arrays. We now meet the push function, which from what I understand is the same as in normal computer science terms, push and pull, using stacks. Okay, so we're going to fill in the function so that it creates a new zombie and adds it to the zombies array. So we have our array named zombie and our struct data type zombie. So let's push to our array zombies. Dot push. Data type zombie with parameters. What parameters does it give us? It should come from the function arguments, which are name and DNA respectively. Hope that's right. Let's check. Perfect. Okay, so now we're onto private and public functions. The Solidity functions are public by default. I think that's with most languages. What are we required to do? It's currently public by default. This means anyone can call it. We need to modify it so that it's a private function. Don't forget the naming convention. I think this is just for the tutorial, but usually a compiler wouldn't care about the naming convention. So let's modify createZombie. First changing the name, and we want to make it private. Chapter 10, more on functions. Okay, so now we're moving on to returning a value from a function. What are we required to do? Create a private function. Let's do that. Called generate random DNA. It will take one parameter named _str of type string and return we're given that it will require the view and not pure. The tutorial does explain what the difference is in using the view function versus pure. I think this has a lot more to do with how the blockchain works, and they do say that it will be taught in later lessons. So we'll be using view. And that should be it. Remember, there is always, if you get stuck, a way to check the final answer. If you're really lazy, but I suggest that you actually try it out. So this has a lot to do with the cryptography behind the blockchain that Ethereum is using and the hashing algorithm. That's a lot more to explain, but I don't think that's necessary now. What we have to do: fill out the body of generate random data, and okay, we want to do typecasting. So we should take the hashing algorithm feeding into it _str and typecast this as an unsigned integer and store it in a variable called rand, which would also be an unsigned integer. So we're basically typecasting this string or whatever type it's in into an unsigned integer. I hope this works. Okay, I've done something wrong. Oh, there's another line of code we need to write. We want it to only be 16 digits long, so the second line should return the modulus. So cool. Chapter 12, putting it together. So we're going to create a public function that takes an input, the zombie's name, and uses the name to create a zombie with a random DNA. Okay, so let's do this step by step. create a public function named createRandomZombie function. We'll take one parameter of type string named name. It will be public, and okay, first line of the function should run the generate random DNA function on name and store it in a integer named rand data rand DNA, sorry, equals. Oh. What are we passing to this? So it will take the name and generate random DNA using that name as the string, putting it into the hashing algorithm and returning a 16 character long string. The second line should run createRandomZombie function and pass it the name and the random DNA that we've just created. Cool. This is a private function. Let's pass it name, sorry, and rand DNA. The solution should be blah blah blah. I don't think that's fine, but let's check. Oh, cool. Chapter 13, events. So an event is the way that our contract communicates with the blockchain in the front end. This is quite high level for the user, so that should be fine for us. And this is where we're firing it. And that's where we're declaring it. So I think we should declare it first. Yeah. Declare an event called new zombie. It should pass zombie ID, unsigned integer, name, and DNA. And how do we declare events in Solidity? Okay, event keyword. We're calling it new zombie. And we're passing an unsigned integer called zombie ID, string called name, and unsigned integer called DNA. Okay, so we've defined our event. Now we need to fire it. Okay, so there was a conflict of a function being called twice. Okay, so we've actually completed our contract. Now we need to write JavaScript frontend that interacts with the contract. So I'm going to pause the video, learn how to do it, and get back. Okay, this is just the front end, then using JavaScript and some Vue.js to make it look really fancy. The first part just uses variables to connect to the blockchain, The spot here is just an event listener for when I actually type in the text box, and this whole function takes the 16 character key that we've generated and kind of like an ID or social security number assigns every few digits to a certain characteristic of the zombie. So if I enter my name, that's the zombie that I would come up with. If I were to do it again, it would give me the same zombie because there is a seed function, so it's pseudo-random, not completely random. And yeah, I think we're done. Congratulations, you've completed lesson 1. I will be doing a video on lesson 2 if anybody likes it or wants it. If you enjoyed this video or stuck through till the end, please hit the like and subscribe button.